11.4, multiplying and dividing rational expressions. So we have a couple of basics on multiplying fractions, right? How do you do it? We multiply straight across, right? So 18 times 4 over 12 times 5. And so we have a couple of options on how to solve this kind of a problem. We can first reduce each fraction and then multiply straight across. So we'll have this fraction there, but then we'll reduce, right? We'll simplify each of the fractions, finding the greatest common factor, and then we'll multiply straight across, and then we'll simplify again, right? So that's one option. Another option is we could just go ahead and multiply straight across and then simplify again. So we're going to utilize both of those strategies here when they're convenient. So let's go ahead and look at the first example. We have this multiplication of rational expressions. And what are we going to do first? Well, we'll just go ahead and multiply straight across. No, what are we doing here? We are simplifying, right? There's an n in the numerator and there's an n in the denominator, so we cancel those out. Over here there's 5 n's and then there's 2 n's, so we cancel out 2 of those n's. So when we do that, we're left with 7n to the 3 over 5n, because in the first term, 2 n's cancel out in the numerator and 2 n's cancel out in the denominator. And then in the next term, we have greatest common factor of 2. So 10 divided by 2 is 5. 14 divided by 2 is 7. We have 3 n's in the numerator and 1 n in the denominator. And so 1 n can cancel out. So that leaves us with n squared in the numerator and leaves us with no n's in the denominator. So we simplified. Now we're multiplying straight across, and we get to here. It's 35n to the 5 over 35. And then finally, we can cancel out the factor of 35, leaving just the n to the 5. So that's example 1. And then also, let's go ahead and look at that same example, but now we're going to multiply first and then reduce the fraction. So if we multiply first straight across, we're going to get 70n to the 8 over 70n to the 3. And so we can simplify that to 70n to the 5. Okay, so 2 different ways. They'll lead you to the same answer. And it's your choice, right? Which way you want to use. And so let's go ahead and look at example number 2. We have our expression involving rational expressions being multiplied by each other. So what can we do? Well, we'll factor the denominator here. Right? The numerator, we can't factor anything out. The denominator in the first fraction, we can. We can factor out a 3 and a y. Over here, we could factor the denominator, this quadratic expression. So we go ahead and do that. Right? So now we've broken everyone down into their factors, and we're looking for common factors. Can we cancel anybody out? Well, you could see over here we have a y minus 5 as a factor. Down here we have a y minus 5 as a factor, so those 2 can cancel out. We have a y as a factor over here, right? A single y. And we have a single y up here, so those 2 can also cancel out. Other than that, I think we don't have any other common factors in the numerator and denominator. So that's what we're left with. We're left with 1 over 3 times y minus 1, right? You can see here that the y canceled out. And on the right side, the y in the numerator canceled out, and so did the y minus 5 in the denominator. So this is what we have left. Right? So we simplified first, and then we multiplied straight across. And so those are 2 strategies that we're going to use in the next problems to multiply these rational expressions.